Here's an explained solution for number 3 on the applications worksheet. So when a plant or animal dies, the amount of carbon-14 it contains decays in such a way that exactly half of its initial amount is present after 5,730 years. The function n of t equals n sub 0, or n naught, e raised to that exponent. And that models the day of carbon-14, where n sub 0 is the initial amount of carbon-14 and n of t is the amount present t years after the plant or animal dies. Suppose that a jar containing a grain is found at an archaeological dig, and that archaeologists claim that it's 6,500 years old. Tests indicate that the grain contains 62% of its original carbon-14. Are the archaeologists correct in their guess of its age? So let's first begin by plugging in what we know. So if we know that the test contains at 62% of its original carbon, that means if I have one, two, three, okay, we have this function. N sub 0 is the initial amount of carbon, okay? And we don't know the initial amount of carbon, but what we do know is that 62% of the original carbon-14 is still present. So if we imagine we divided by n sub 0 here, this amount would be 0.65, okay? So another way we could think about it is, if the amount of carbon that we had initially was 100% or 1, okay, and the test contains a grain that contains 62%, so 100% is there, 62% is left, then we could use those numbers if you would prefer. Okay, so when we divide by 100, now we have 0.62 equals e to that bigger, or tiny exponent rather. Okay, so now this is an exponential form, and we can write it in log form. So negative 0.00012 t equals ln of 0.65. And then when we divide by this whole exponent number, we end up with ln 0.65 divided by negative 0.00012. So let's plug that in. We got ln of 0.65 divided by negative 0.00012, and we end up with 3589.9 years old. So they had predicted that it was 6,500 years old, and that would not be the case. So they are not correct.